Yo, yo, YouTube, Twitch, Kick, all at once, say it with me, all at once. Organic chemistry, substitution reaction. Let's go. But before I go, I just need to confirm if it's working properly. Just a minute, okay? That's not my fuck. Just a minute. Switch. But yeah, looks like it's working. It's working. And the titles are correct. Yes. Yes, yes, yes. The titles are correct. Okay, okay. Okay. Okay, okay. Kick. How we kicking? How we kicking? We kicking, we kicking. Kick is kicking. Oh, next one. Ah, fuck. I gotta type in. Twitch. We twitching? We twitching or what? We twitching. We twitching. Hell yeah. Hell yeah. Oh. And all for free. No subscription. God damn it. That is crazy. I just need to know how the chat is working because I got a new chat system. I hope it's working. Let me just test it if it's working. Okay, let me just test that. Let me just test if it's working. No, that's not it. That's not it. Okay. I can. Yo, this shit working or what? I'm not getting it. Okay, that's not good. That is not good. Okay, that worked. That's like a spam message. But that's from the app though. At this point I need someone who is from the outside. I guess whatever my account is, it's just not showing up. Okay. Well, you know what? It's not like I care. Organic chemistry. Or is it? Aromatic substitution, I guess. Which PDF number was I? Why do I hear myself in the background? Oh, it was just me. No, okay. Okay, but what is name of the PDF, as in we are in which of the sources that I just gave you. Based on your discussions regarding Walden's inversion and subsequent pages on solvent effects, we are working with the source titled Lecture 3 Reaction Basics. Okay. That's what I was asking. Which PDF, gang? Which PDF? This will just show you in it. I guess Gemini, you can go away. Oh, there's no, the vertical stream is not there. You know what? Just a minute. Gemini, I need you for a bit. Damn, a lot of GitHubs. I am going through GitHub a lot. Yo, my boy, not right now, gang. I don't know if you're here, but not right now. Uh, universal.pkg. Oh, it's gonna end the OVS. Okay, I'll do it next time. Don't worry. Yep, if I open the plugin, it's gonna end the OBS. Fuck, I don't have any way to confirm. No way to confirm the chat is working or not. But hey, yeah, it is what it is. It is what it is. Before the correct check-in, you were focusing on the solvent effect on nucleophilic substitution reaction. Oh, okay, solvent. Depending on the polarity of the starting material, transition state, and product, the reaction can either be sped up or slowed down by more polar proctic solvent compared to the reaction in non-polar solvent. DMSO can solve. Okay. Depending on the polarity of starting material, transition state, and product, the reaction can either be speed up or slowed down by more polar proctic solvent compared to a reaction in a non-polar solvent. What happened to all the good music? Where's all the good music? Depending depending on the polarity of the starting material transition state, the reaction can either speed up or slow down by a more polar solvent compared to the reaction in a non-polar solvent. Okay, but no, not Himmelbach. Not Himmelbach. It's Christian Klampfer. Okay, they just started. No, I need the introduction. Mm-hmm. Mm. Should I? Should I? Oh, come on. How to switch between tabs? Whoa, whoa, whoa. OBS crashed? Encoding overloaded. What can I say, OBS? You're having a hard time, huh? Gemini's over, okay. Before your current check-in, rule AB duo, we were classifying how to choose between polar, protic, and aprotic solvent. Polar or polar and non-polar solvent. Okay, okay, can you tell me how many types of solvents are there in this context? Because I know polar and non-polar ones. In the context of lecture notes, solvents are classified based on two main criteria, polarity and proton donating ability. Polar protic solvents, polar aprotic solvents, apolar aprotic solvents. That's it, okay. How far did I write in my notes? Organic chemistry, my notes. Oh, where's my notes? Yeah, my notes. There we go. Got them. Whoa, whoa, this one. How far did I write? I wrote till... Oh, that's a lot. That's a lot. Should I move the camera? Because it looks like I should. Because my tablet's right down here. Writing scene. Wow, Restream is again here. Oh, I forgot about that. Gotta make that change. But now we're good, right? That's pure. Sources. No. Replace. Browser, right? Browser chat. Add existing chat. And chat goes down here with somewhere here. Let me just test the chat if it's working. Trigger a fake. That's how a fake message looks like, because I don't have real messages. Yeah. Good. Ah, two screens now. What? Why is it different now? Remove. I'm sorry. I gotta get a new one. Add. Now, there we go. If we get it to the left, and my stupid ass to the bottom, we could get more space, huh? Kinda. Kinda. Not too much. Yeah. It's the best. I ain't complaining. I ain't complaining. Okay. How many types of solvent? 3 types, basically. Protic, polar protic solvent. Polar aprotic solvent. And apolar, non-polar, aprotic solvent. I would prefer non-polar because I don't want to use unnecessary vocab. Aprotic solvent. Bing, bing, bing. So, example of polar aprotic. Polar aprotic water is polar aprotic DMF acetone. Structure of acetone though? Must stupid as forgot. Yeah, that's acetone. You know what? We could make it even more simple, right? Acetone. There you go. One hour. Let's see in 1 hour how far I can go. 1 hour. 45 minutes. 30 minutes. 15 minutes. 20 minutes. Let's go. Skolis, 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 skolis. These are polar molecules that cannot form hydrogen bonds because they lack an acidic hydrogen. Polar molecules that cannot form hydrogen bond because of lack of acidic hydrogen. Form hydrogen bonds because the lack of acidic hydrogen, whatever that means. me get my special military grade water. This is the cucumber water. Yo. Yo, yo, yo. I'm doing everything except study. Apolar. These solvents have very low dielectric constant and cannot form hydrogen bonds. Examples of apolar, nonpolar, hexane, benzene, diethyl ether, benzene, better. Dimethyl sulfoxide, dimethyl not solvents have very low dielectric constant and cannot form hydrogen bonds. Again, dielectric constant. I heard this terms before. Having very low dielectric constant and cannot form hydrogen bond and form hydrogen bonds. They're generally not useful for nucleophilic substitution involving ionic reagents because the starting material won't dissolve in them. Additionally, they cannot stabilize the polarized transition states required for a reaction to proceed. They're generally not useful for nucleophilic substitution involving ion. Okay. Oh, fuck. Let me know, how is the polar protic solvent helping in specific substitution reaction and not helping, in fact slowing down certain reactions. Based on the lecture notes, polar protic solvents play a dual role in substitution reactions, acting as a major accelerator for one mechanism while significantly hindering another. How polar protic solvents help in SN1 mechanism. The rate limiting step is the formation of high energy carbocation intermediate, stabilization for transition state. Stabilization of transition state. The transition state from the neutral starting material involves a significant increase in polarity. A polar protic solvent is ionizing, meaning it stabilizes these developing charges through solvatization. The rate limiting step is formation of high energy carbocation. Stabilization of transition state. The transition state from the neutral starting point to charge intermediate involves a significant increase in polarity. The polar protic solvent is ionizing, meaning it stabilizes these developing charges through solvatization. Solvatization as in solvatization of anions by protic solvents through hydrogen bond. Okay. Solvatization means, I think I should write that. Means the solvent molecules surrounding certain solute the process where solvent molecules attract and solute ions or molecules in the solution. Yep. Process of or reorganizing solvent and solute molecules in the solvation complex involves bond formation. Process of reorganizing solvent and solute molecules into solvation complexes and involves bond formation. Involves bond formation, H bonding, and van der Waals forces. Solvation of H2O equals hydration. Yo, that's slow. You see that? That's when the computer tablet gets slow. helps, SN1 hinders, SN2. Stabilize the carbocation. 15 minutes, yep. Carbocation. Cage effect on the nucleophiles. Cage effect on the nucleophile. Effect on nucleophile. Whoa. No intermediate lowering activation energy surrounding subreddit. Decreases activation energy. Decreases activation energy. I'll write the rule later. Okay, now that's taking a long time, bro. Ow. There we go. Oh. Whoa. No way. It was the other way? No way. I did not realize that. Did not realize that. 20 minutes? Okay. Not good. This is not good. That's taking a long time. It's taking much longer than I thought. Which is so Yo, what happened? The fact that just, the fact that when Notebook LM gave up, I also gave up. Yo, that's bad. It's not how it should be. Aprotic solvents accelerate SN2 reaction by leaving nucleophiles unsolvated and reactive, but poorly support polar aprotic. Okay. Accelerates SN2 reaction by leaving a nucleophile unsolvated and reactive, will poorly support SN1. Non-polar solvents halt both pathways because they cannot dissolve charged ions or stabilize transition states. Polar aprotic solvents strongly accelerate on SN2, poorly supports or disfavors the mechanism. They lack acidic protons, meaning they cannot effectively stabilize or solvate the carbocation intermediate or departing leaving group relative to the polar aprotic options. Options? Did I say options? Options, god damn it. Non-polar solvent, example hexane, toluene, diethyl ether. Effects on SN2, extremely slow and non-functional. Non-polar solvents, extremely slow and non-functional, extremely slow and non-functional. So it's basically the non-polar aprotic solvent, polar aprotic, non-polar aprotic. Is there no non-polar aprotic? No, aprotic. No, there's no such thing as non-polar protic solvent because the properties required to be protic inherently creates molecular polarity. Okay, makes sense. Makes sense. No specific effect on SN1. That was not. Poorly supports or disfavors the mechanism. Strongly accelerates the reaction. Helps. How does it do though? They dissolve cations but do not form hydrogen with the anions. So it's not a nucleophile. They dissolve the cations as in the leaving group, leaving the nucleophile without a stabilizing counter-ion, making it a much stronger and more reactive nucleophile. Okay, leaving the nucleophile without a stabilizing counter-ion. 30 minutes? Whoa, time is going very fast. Time go fast. Time go very fast. Dissolve cations. Dissolve cations plus results results in a more reactive nucleophile They lack acidic protons, meaning they cannot effectively stabilize to solvate the carbocation. No. No acidic OH or NH protons, leaving effectively, therefore no stabilization for or a leaving group. Nonpolar. Extremely slow or non-functional. Nonpolar solvents are not suitable for SN1 or SN2. And separate the nonpolar media cannot stabilize the separated electrical charges, causing activation energy to skyrocket. Both are non-functional. Hinders SN1. So if you want to stop hinder, so if you don't want SN1 or SN2 to happen in general, I think you could use non-polar aprotic, like a benzene, like my boy benzene. Bro's useless. First step of SN1 reaction creates a high energy carbocation, and separating nonpolar media cannot stabilize the separated this solvent cannot stabilize the carbo that just formed. Yo, the chats are here, but yo, I'm sorry, gang. I did not see the chats, but what the fuck? Okay, so looks like my new chat system is not working. Interesting. I thought it was working. Okay. It's not working. It's not showing up the chats. Which is making things hard. Charmond kaisa hai? Yo, bro, get the fuck out of here. Appreciate you for checking out the stream, but I did not see the chat. It should be coming in here. You were studying free radical reactions. Okay. Is it working now? No, the chat is still not showing up. Just a minute, gang. Please sign in. Okay, I need to sign in. No, clear all. WebSocket standard. Let's go standard. What is this? Okay, it's locked. Okay, but where's the chat though? Where is the chat? Wait a moment. Okay, so the chat is still not figured out yet. That's weird. So what's the case for Kick and Twitch? Is there some... Yo, Kick is always... It's always like, yo, homie, send me your Discord. I can help you get 1,000 followers. Classic Kick, I guess. I don't think I missed the Kick chat. Twitch, how is it Twitch doing? Just load. Okay, no chat from Kick. This is weird. The chat is not working. Lot of settings, lot of settings on this app. I don't know how to use this. My stupid brain not braining. So it hinders both SN1 and SN2. The worst thing is I can't test it. Just a minute. Yo. $45. Is that gonna show up? It is not. Weird indeed. First step, nonpolar cannot stabilize these separated as SN1, SN2, not suitable. Nucleophiles are not soluble. Cannot dissolve. Less relevant effects on SN1. Polar, aprotic, less relevant. While they can solve the carbocation electrophile via electron pair donation, they are not as effective as promoting the initial ionizing step. As polar protic, a good ionizing solvent is typically required to okay. Okay. Less relevant. Okay, that's what I wrote, right? No specific effect. Yeah, so that's basically solvent. The ethanol reaction rate so does that mean ethanol or pure ethanol does not help or hinder? Solvent effect on SN2 with charged reagents, most common case. In chemistry, relative rates are used to show how much faster a reaction is compared to a standard by setting ethanol to 1. The table makes it easier to say that water 100% is 1,200 times faster than ethanol. Okay, I would prefer water to be 1, and you show that if you put the ethanol, it's gonna be, I don't know, 1,200 times slower. Does ethanol help or hinder? Whether ethanol helps depends on what you're comparing to. Okay, I get it. So solvent effect on SN2 with charged reagents, most common case. Most often SN2 reactions slow down by protic solvents due to strong solvatization of nucleophile by solvent. Reaction speed significantly by the use of polar aprotic solvents. Okay. Reactivity of organic compounds. Structure, abbreviation, dielectric constant, boiling point. Why was dielectric constant mentioned? Where was it mentioned? Don't remember. Parts where they at page number 195, can you help me with the statement at the last, which is important to distinguish types of reactions. Reactions, I meant how reaction proceeds. If the reactants are less charged than the transition state, a polar solvent speeds up the reaction. You know what? Let me restart the laptop, the tablet, because this is not it. Slow as fuck. What? I closed it. Oh, you can't close it? You can. Looks like I gotta. Those are some important stuff, god damn it. God damn it. I can't just show off my important stuff like that. That's so weird, I can't close it. Fuck. But why is it all three chats? I want it as a combined chat. No, it's still not what I wanted. Ugh. Well, I still haven't figured out the chat looks like. It's like I'm waiting for the stream to be over. No, I'm not. 1 hour. It's 1 hour is over. less charged than transition state, then a polar solvent, polar protic solvent, right? General rule. Speeds up the reaction. Starting materials are more highly charged than transition state. If reactant are more charged than transition state, so this is talking about SN1. But in SN2 there is no transition state, so what are you talking about? Are you talking about product? There's no transition. So I'm guessing you meant the product. This defines during a transition state as a highly reactive, short-lived, partially formed bonds that cannot be isolated. This certain specific transition state, carbon is simultaneously bonded to both the nucleophile and leaving group. Yo. I can see Islamic path. I can see your message here, but it's still not visible on the chat. Interesting. I don't know why. Yo, you send the message on 40. Okay. Hello, bro. How are you? I'm doing pretty good. Did you listen something you heard? Is it about the protest? I did. While this is true that intermediate is highly charged, rule specifically refers to transition state because this state is which determines the reaction speed. Gatekeeper of any reaction, the speed is governed by the activation energy, which is defined as the free energy difference between the reactants and the transition state. Intermediate sits at the valley after the energy hill. Even though the intermediate is highly charged, the reaction cannot happen unless the molecules first reach the peak of that hill, the transition state. transfer than the transition state less or aprotic. Solvent speeds up the reaction. It's still slow. That tablet is still slow. The peak state the molecule is at when it's forming new bonds applies to both SN1 and SN2. Highest energy point. Most often SN2 slowed down by protic solvents due to strong solventization of nucleophile by the solvent. Reaction speeds up significantly by the use of polar aprotic solvents. Stabilize the transition state and dissolve the ionic reagents. Totally apolar solvents not useful. Insoluble reaction partners, generation of polarized species. Example, transition state hindered. Okay. Protic solvents can form hydrogen bridges. The higher the dielectric constant, the more ionizing polar is the solvent. Dielectric constant, okay. I have seen the use of dielectric constant. Could you let me know what exactly is dielectric constant involved here? Also, let me know what dielectric constant was, because I kind of forgot. Also, let me know, is the dielectric constant important for the solvent molecules or the nucleophile or the leaving group? Oh no, that's not good. Dielectric constant is a physical property of the solvent that measures its polarity and ability to separate and stabilize electrical charges. Physical, oh no. Measures a material's ability to store electrical energy in an electrical field. That's where I heard that. Okay, it was in physics. Electric constant involved. In organic chemistry, the dielectric constant of a solvent directly determines whether a nucleophilic substitution reaction follows a unimolecular or bimolecular pathway. It serves a macro-scale measure of the solvent polarity, dictating how well the medium can separate and insulate opposite electric charges from one another. Organic chemistry, the dielectric constant of a solvent directly determines whether a nucleophilic substitution reaction follows a unimolecular or bimolecular pathway. It serves a macro-scale measure of solvent polarity, dictating how the medium can separate and insulate opposite electric charges from one another. Okay, I need more explanation on that part. Could you explain this again? Because I didn't fully get it. So we are looking into the dielectric constant of the solvent. And could you also explain what dielectric constant is here on a molecular scale? Because I'm having a hard time visualizing this. Connecting to physics property like dielectric constant to a flash flow. Okay. What dielectric constant means on a molecular scale? When we measure a solvent's dielectric constant in the lab, we're measuring the molecular flexibility and structural polarity. On a molecular scale, a solvent with high dielectric constant has molecules that act like tiny, high responsive magnets. They possess two distinct features. They have a very negative end, usually an oxygen or nitrogen atom, and very positive end like hydrogen or carbon atom. High mobility, they can quickly spin, rotate, and align themselves. Imagine putting a pair of opposite charges, a positive carbocation and a negative leaving group, into a high dielectric solvent like water. The molecular shielding effect, the water molecules will instantly swarm the ions. The negative ends, oxygen atoms of dozens of water molecules turn to face the positive carbocation. The positive ends of the other water molecules turn to face the negative leaving group, because the ions are completely... Wait. When we measure a solvent's dielectric constant in a lab, we are measuring the molecular flexibility and structural polarity. A solvent with high dielectric constant has the molecules that act as a tiny, highly responsive magnets. They possess two distinct features: strong, permanent dipoles. They have very negative end and a positive end. High mobility. They can quickly spin, rotate, and align themselves. Imagine putting a pair of opposite charge into a high dielectric solvent like water. Molecular shielding effect. The water molecules will instantly swarm the ions. The negative ends of the dozens of water molecules turn to face the positive carbocation. Positive ends. So basically, solvents with high dielectric constant are polar protic solvents, and solvents with no or zero dielectric constant is did I press 0? Is a non-polar aprotic. The dielectric constant can never be 0. Even a complete vacuum has a dielectric constant of exactly 1. And the most nonpolar solvents like hexanes have dielectric constant around 1.9 to 2. Realigning the categories. While your intuition is mostly right about the relation between polarity and dielectric constant, they don't perfectly match up into just two categories. These are actually three distinct groups. Group 1, high dielectric constant, hydrogen bonding, polar protic. High to moderate, no hydrogen bonding, polar aprotic. Low, non-polar aprotic. Okay. Oh, I could have mentioned the dielectric constants. You know what, I will. What? High dielectric constant. Moderate. What was this? Low. Aprotic solvents often used for SN2 reaction due to good solubility of charged species therein and rate enhancement compared to protic. What was the reason for aprotic being used? Helps. Results in a more reactive nucleophile. Dissolves the cations. Okay. The strength of nucleophility is dependent on its basicity, polarizability, solvatization, and steric effects. Reaction rate of SN1 reaction independent of nucleophilicity of the reagent, comparing nucleophiles with same attacking atom. Stronger bases, stronger nucleophile. Okay. Well, YouTube, I'm in the stream, and the next stream should be the chat should be ready within the next stream. Peace out.